Hi, welcome to the latest edition of Trends in AI. My name is Jakub Zavrel from Zeta Alpha, and today we have on our show a special guest, Stephan Zheng, who happens to be native in the Netherlands, moved to the US, and has had so far a distinguished research career. Kind of focusing on AI and economics, and that's the main topic that we are going to be talking about today. Welcome on the show, Stephan.
Yeah, thank you so much for having me.
So first of all, I'm really curious kind of how you got to where you are today. You started out in theoretical physics in the Netherlands, and I know that great physicists can almost do everything, but what was your path to get into AI, and in particular, kind of your work in using AI for economic modeling?
Yeah, it's been a while, but in my undergrad studies, I started doing math and physics, and I was really fascinated by trying to understand the universe. Physics is a fascinating field because you can make models and predictions about things that you otherwise can't really see, right? So that really fascinated me. And so I actually spent a lot of time on theoretical physics and studying ever more complex mathematical models of certain, high energy physics. And that was really interesting and fascinating. And it's sort of mind-boggling how the universe actually turns out to work. But also at some point, it became very abstract. So at some point, I was studying, theories of, for instance, what the interior of a black hole might look like, right? So, and that's really great, right? So, for instance, people have made these beautiful models called string theory, right? And string theory sort of studies the extreme universe, right? Like what happened at the Big Bang, what happens inside black holes. So that was really fascinating, but at the same time, it also was clear that a lot of those models couldn't really be tested anytime soon. And so in my PhD, I started looking for something else, right? And arguably the other most fascinating thing in the universe is really people, right? So, and I was fortunate that this is about 2013. When I started to think about what else to do research on, deep learning really crashed onto the scene, so to say. Or this was about 1 year after ImageNet basically was crushed by deep learning, right? And that sort of started off the whole deep learning revolution. And so it was sort of like an interesting time to start to do AI, so to say.
And so doing deep learning is one thing, and a lot of great researchers in AI are motivated by wanting to understand the human way of thinking, right? Like human cognition. But how did you kind of roll into this use of AI methodology for economic modeling? Because that's yet another sort of different perspective on human behavior, which is quite external. You're not actually looking at the individual human, but at groups.
Yeah, for sure. I mean, if I look at my personal research history, there's two phases, I would say. So like my PhD, and then like the last 4 years when I was a researcher at Salesforce. And so I started out with studying basketball players. So my PhD advisor had a very unique data set of NBA basketball players. And so, there were these top-down cameras that were tracking where all the players were going, and they were labeling what these basketball players were doing, right? And it was a very unique data set for many reasons. Like it was very high resolution. It had like this team element in it because you had two basketball teams competing with each other. And with deep learning, some of my early research was really about trying to deconstruct levels of human behavior And then
Or at the computer vision level in some sense.
not at the computer vision level, because that the data set already took care of the vision part, but it was really about predicting where individual players would go. And so you could ask the computer, if you were Kobe Bryant, right, and you had the ball, where would you go? Where would you run to? Or would you pass the ball to your teammate? And that's such a, and with the data at that resolution that we had at the time, so the data was captured at about 30 frames per second, more or less, right? So you had this sort of pretty high resolution video. Well, not, I'm saying video, but really what you had is like these tracks, these XY coordinates in time. And so it turns out that deep learning was really good at modeling that human behavior from the data, right? And part of my research was really looking into decomposing that behavior in terms of, for instance, short-term and long-term decision making.
Right.
And so towards the end of my PhD, then I started to become very interested in modeling teams and like how do people cooperate. And then when I became a researcher at Salesforce, I kind of continued that trend because you know, as you said, like, you know, for instance, you know, why is collaboration so interesting? Well, one reason, for instance, is that like humans and computers would communicate, right, with chatbots, for instance. And so a lot of intelligence, so to say, you can think about is not in a vacuum, right? And so intelligence is usually formed in a community, right, where we're constantly communicating with each other, we're responding to each other. And so generally speaking, this sort of multi-agent view of AI is something I became very interested in. And so that rolled into economics, because in economics, people think a lot about the incentives of human behavior. It's like, not just like, can you use deep learning to predict what the human's going to do? But, you know, in economics, like a very important question is like, why do people do what they do, right? Like, why do people cooperate? Why do people on a basketball court go to the left instead of the right? And so that you know, that study of incentives, that's one of the reasons that I started to do economics too.
Yeah, well, I guess the sort of old-fashioned economics theory is they do that because they're perfectly rational beings, given the information that they have, right?
Yeah, and then so in traditional economics, you know, economics is a huge field, right? So but yes, like, you know, rationality is a very basic assumption. People do have models of bounded rationality, so, you know, it's so bounded rationality means, so rationality means something like the human's like this perfect computer, right? The human knows exactly what their numerical objective is that they should optimize, and then, you know, the human as a rational being can then find the optimal behavior, right? The behavior that optimizes that numerical score. Yeah. But, you know, and that's not always true, seemingly, in the real world. So, but yeah, you know, like there's this very general study of like what drives human behavior in economics.
Is that kind of that context? Does that naturally lead to these sort of multi-agent reinforcement learning systems that you've then later made use of?
Yeah. I mean, it's a very natural framework for many reasons. So in multi-agent reinforcement learning, you think of the world in terms of a simulation, and all the agents in the world are controlled by a reinforcement learning model. And so that's a very attractive picture, because you can use reinforcement learning to ask questions like, if I give you a numerical objective, what is the optimal behavior? And so AI people have shown that reinforcement learning methods are very good at finding pretty good behavior. It's not always clear if you find the optimal behavior, the theoretically optimal behavior, but you find behavior that is, you know, gives you very high performance. Right. But the thing about reinforcement learning that's conceptually so interesting is that it's very flexible. So if I change the numerical objective from a purely rational objective to a boundedly rational objective, it's no problem for reinforcement learning. It will still give you a very high performing policy, right? And so in our research, for instance, we showed that this is really interesting, because if you think about optimizing government policy using reinforcement learning, you can go away from the traditional objectives that economists have been using, right? So the traditional view on economics is, for instance, or on a traditional view on economic policy, for instance, is that the government is maximizing this sum of everyone's happiness, everyone's utility, right? So the government magically can add up everyone's happiness. So, every person, you, me, we all have a number, right? The higher the number, the happier we are. The government can add up all these numbers somehow, and then find the best policy that's going to optimize, that the sum of all those numbers.
Yeah.
And that's unrealistic for many reasons, right? And so in our own research, we said, well, what if we just actually try to optimize directly for things like economic growth?
Yeah.
Or
So
economic
that's this paper, right? That the AI Economist, I think that's the paper that you kind of got a lot of attention with, including sort of mainstream press and economists who had to acknowledge that, in fact, this way of optimizing policies might lead to very different outcomes.
Exactly, yeah. So yeah, what you're showing here is the very first version we put online.
Yeah,
and
the archived version, I think.
The archived version, yes. So there's a more recent peer-reviewed version of this in Science Advances. And yeah, I'm pretty happy with this work for many reasons, because as I said, one of the interesting sort of features of reinforcement learning is that you can ask it to optimize a policy for exactly what people care about, right? And not some fictitious objective of total utility, which is immeasurable, right? Like we can't actually measure total utility, but you can directly optimize for economic equality, right? Economic productivity. And we can measure those things. And that's also what people talk about, right? And so one reason is, and there are multiple reasons why reinforcement learning is a really interesting framework for economics. But one of the sort of methodological reasons is that you can directly optimize for what people care about and what society cares about.
And so can you, just for people who haven't read the paper, briefly summarize kind of the outcomes of your policy optimization? What kind of tax policies did your algorithms discover?
Yeah, so the AI tax policies in this work that it finds are not, they don't really resemble classic economic tax policies. So what it finds is that, so basically what we do is, like, we have this simulated economy. It's relatively simple. It's not the real world, but it is complicated enough that you can't really use economic theory to ask questions like, what is the optimal tax policy in this world? Yeah. And so what the AI finds is that there's a sort of like up and down tax schedule that's optimal, or at least it does better.
What do you mean by up and down exactly?
Yeah, so the way taxes work is that
they're progressive, right?
Yeah, so it's either so basically, like, the tax schedule says, like, you make a certain amount of money, let's say $10,000, and then over the, like, for the first, let's say $2,000, you give 10% to the government, and then in the next bucket, right, let's say the next $2,000, you might give 20% to the government, right? Yep. And so on. So that will be a progressive system where the more money you make, the higher the higher buckets of money are being taxed, yep. Right? So,
or you have a flat rate, or those are kind of the flavors that you commonly have, right?
Yeah, exactly. So in classic economics, the sort of the very common models for this that economic theory comes up with is progressive. The more you make, the more you start to pay at the top end, or regressive, where the more you make, you actually make less. Sorry, you have to pay less in taxes, which is, it's fairly counterintuitive, but there are cases where you can argue that that's actually better. And that's actually what the economic theory predicts in some cases. And so, but what happens in this case is that because the simulation is, well, first of all, the simulation is more complicated than a lot of those classic models are studying. And the AI, again, like because you're using this reinforcement learning as a tool to model both the government's tax policy, but you're also modeling how people are responding to those taxes simultaneously, right? It turns out that there's like this up and down schedule where that works better. So what that means is that at the lower end of your income, sometimes you actually pay higher taxes. Then there's this sort of valley in the middle where there's a part of your income where you actually pay very low taxes. And then at the very high end, again, you start to pay high tax rates again. And so that is a bit counterintuitive.
Is it immediately thinking like if your utility function is to optimize also for equality, that makes sense, right? But isn't it like kind of baked into your loss functions for your reinforcement learning, or was it really surprising to you that you got that outcome?
Yeah, I mean, we didn't predict that this would be the result, this up and down tax schedule. And I want to be careful to say that I'm not saying that in the real world we should now start to use up and down tax schedules all of a sudden. And yeah, like I mean the connection with the objective function is very interesting because one common question we get is why is the tax schedule this way? Like why is it? And certainly it has something to do with the fact that you're optimizing for this combination of equality and productivity, because in the simulation, in this simulated economy, the government uses the tax money to give back to the people, right? And so there's this balance that this tax policy manages to achieve where there's like really, at a high level, the way I think about it, there's two forces at work. One is that, if you lower the tax rate, right, as a government, you make it more attractive to work because you'll pay less in taxes. But at the same time, if the tax rates are high, the government can raise more revenue and they have more money to redistribute, right, and to make things more equal. And so one way to interpret this up and down schedule is that there's some balance between these two forces where at the low end, right, you can raise the taxes, in fact, because you lower the tax rates at a slightly higher bucket. So these agents, these reinforcement learning agents, they start to realize that if they just work a little bit more, they can hugely benefit from low tax rates, and that the price they pay in the beginning, so to say, the high tax rates is actually okay, right? It's more attractive, so to say, to work a bit more and to end up with your income in this valley, to really benefit from the low incomes there. Yeah, and so like that's one way that you can reason about it, right? Yeah, and so then I think it shows that these AI policies, they understand the world in some sense a bit better than real people do, right? And so that's quite interesting.
Now these AI policies kind of hit the real world. And I guess the first confrontation is actual economists reading your paper, and maybe even policymakers reading about your paper in the more mainstream media. So what were some of the first reactions, and what is your assessment of real world success with this kind of approach? Like, do you think that AI policies will actually, like, it's a good idea to have AI policies actually be implemented in the real world, or how does the confrontation with real economic policy making go?
Yeah, that's a huge topic, right? And then there's a lot that's involved with that. I think that we certainly shouldn't deploy the AI policies that we've come up with so far directly into the real world for many reasons.
Let's start with the first reaction that economists have when they read your paper. What are some?
Oh, so when they look at this, I think that there's this mixed response where some economists, it really is this sort of Rorschach test, if you will, of an economist, right? Some economists will point to this sort of from a more computational point of view, and they'll say, yeah, like, the fact that you're modeling the government's policy with reinforcement learning, but you're also modeling the adaptation of the agents in an economy. with reinforcement learning. That's very novel, and that's definitely something that classic economic theory just cannot do, right? So it's clear from a sort of methodological point of view that we're solving a very hard problem. And it's clear that like classic economic theory doesn't really like go that far, right? Then then there is a question that most economists will raise, is that like, okay, but then what does the solution mean that you found, right? Like, how do we interpret that? And that's hard, because most economists, when they do economics, they do think like a physicist. They want to understand how the world works, right? So they want to have,
basically.
Sorry?
Causality, basically. Kind of.
Yeah, that's part of it, right? Yeah, that's part of it. And so the holy grail in some sense is to have some sort of perhaps causal model of if I do this, then this happens in the economy, or this result, or this economic growth can really be explained by these and these causal factors, because for instance, population growth, unemployment rates influence economic growth in such and such a way, right? And I have a very clear understanding of what this causal relationship looks like. And that can be very hard to extract from like the current generation of AI modeling, right, for economics. So that's something where we definitely have to do a bit more research on to make that, make that understanding more accessible, so to say. And then like the other thing that most economists will sort of latch onto is the simulation, right? They will say, well, this economy is maybe very simple, or maybe you didn't include population growth in this simulation, right? And so then there's this notion of realism, or the lack of realism, and then because of either you don't have realism, or you have too much realism maybe in some cases, then the question is like, then are the policies that you come up with, like how are they relevant to the real world, right? If there's this mismatch between the simulation and the reality. And that's I think another topic for research that's unsolved. It's like the sim to real transfer problem, right? You develop this policy in a simulation, and you're asking, can this be used in the real world? And what are the conditions under which you have something like robustness, for instance, like, if the world is not like a simulation, would the policy still work, right? And
that's in some sense that's very much tied to like the realism and the complexity of your simulation, right? And I think maybe just to clarify a little bit, what kind of scale do these simulations operate on, and like how many agents are you actually modeling in work like this?
Yeah, so in this first paper, we went up to 10 economic agents.
Right. So it's
and one government.
Very small scale in some sense.
Yeah, like it's very small scale. And so this first paper was really focused on this methodology, right? So, again, the government uses reinforcement learning, all the economic agents use reinforcement learning, and multi-agent reinforcement learning is a very, very hard problem, right? So you have to do a lot of tricks to make the machine learning work. But we have follow-up work where we've made the simulation bigger, so with some interns, we have projects where we added companies, and we have somewhere between 100 and 1,000 economic agents in the simulation, right? And we also have been developing open source simulation software that lets you run those simulations that are a bit bigger. So, I think that gap, right? Like
I think we have a slide on that.
Oh yeah, exactly. So WarpDrive is this open source simulation framework where you run this economic simulation with thousands of agents on a GPU.
Thousands of agents, okay.
Yeah, and so
and does that really make a difference for the kind of let's say economic modeling outcomes, or is the sort of richness of your toolkit already big enough just by the fact that you use reinforcement learning, or does the quality of the simulation substantially increase with scale and order of magnitude?
Yeah, like in some sense, like the level of realism goes up, right? Because what happens is that you can have more diversity among the agents in your simulation, right? So, one of my interns, Michael Curry, found that high level, the AI policies, again, will outperform the classic policies when you have more economic agents, when you have companies in the simulation. I mean, the policies won't look exactly the same, but if you look at that numerical objective, right, like equality of productivity or total utility, you will beat the economic baselines. But yeah, like I think what from an economic modeling point of view, certainly these models can be more realistic, because, for instance, one of the things that even in the 10 agent version, right, that we had, there's a notion of skill, or skill differentiation, meaning not everyone goes to college, right? There's like a difference in education level in the world. So that's like one example of how agents can be different. And once you have more agents, you can differentiate these agents among more dimensions, right? So maybe where they live, or what school they've gone to, or what kind of profession they do. So right, and so that's really like the room that you get, right, by having more agents. So yeah, so I would say that in that sense, like you definitely will get more realistic simulations.
So for those interested to get into this, WarpDrive is on GitHub, so you can get started right now. And so modeling these tax policies, I think economists have been doing that using more classical tools, but more recently you have embarked on research which is really about a much more complex framework. Actually, well, maybe you can explain it yourself, but it's about negotiating agents, right? Like in global climate control talks, how the different parties negotiate with each other. Can you explain a little bit about that line of work?
Yeah. So this is like one of the most recent ongoing projects, I would say. It's also like a public project that anyone can join. Yeah, so like it's called AI for Global Climate Cooperation. And so we're asking how countries can work together more, right? What are the right incentives and mutual agreements that need to exist to incentivize countries to work together on mitigating climate change. So what we've done here is we've again made a simulation of the real world, right, where we model the economy, but also the global climate. And so we have multiple countries. All these countries have their internal little economy, but they can also trade with each other, and they can also talk with each other, right? So what we're asking here is that if we look at climate change, there's no sort of scientific doubt anymore that climate change is real, right? Whatever the cause is. And we need to find ways to mitigate the rising temperature in the world. And so what's unclear though in climate change research, I would say, or climate change policy making, is why countries would actually coordinate their efforts together and actually stick with their agreements, right? Because like the climate policy and climate negotiations in the real world are decentralized. There's no central authority like that acts like a police officer and says, well, you should talk to each other. You should talk about maybe you should send some money to the other countries, and the other countries should maybe like invest more in green energy, for instance. And if you don't do that, you're going to be punished, right? That's not how the real world works. And so if you think about this as a negotiation game, right, there's a lot of complexity in these international negotiations, and it's very easy for any sort of agreement to arise. And it's even harder for countries to actually stick with their agreements for various reasons, like domestic politics, global politics. There's many factors that influence that process. And so if you look at the climate report from the IPCC from last year, they actually started to look into these kinds of questions where, for instance, they say, well, what if certain countries follow through or execute certain climate policies? How does that impact our climate simulations, right? And so that there's this whole like question around like what kind of policies would countries have, and what is their impact in the world. And like, they've shown that the impact on global temperature is like really significant, right? Like you can go from anywhere to 1.5 centigrade temperature increase in 50 years or 100 years, all the way to +5 degrees centigrade, right? So it's like basically life is okay or life is hell, essentially, right? Like, and people have really shown that like whether or not countries follow through on like certain climate obligations and climate policies is really a key factor, right? And what is clear high level again is that global cooperation is really crucial to really make it attractive, again, to have to provide the right incentives for countries to actually execute certain climate policies, right? And so in this project, we're basically like asking this question, like, can you use these AI simulations to study like the effect of certain negotiations? Can you study the certain agreements that countries would make? And can you show using AI simulations that the incentives are actually correct in the sense that countries will actually stick with those agreements, right? And then eventually, what does it mean for the climate? So that's what the project hopes to contribute to, right?
Right.
In the same
time. So I was fascinated by this work also because roughly around the same time, a little bit later, people from other research groups, among others from Meta and DeepMind, started working on other sort of multi-agent systems, playing negotiation games, among others, the work on CICERO from Meta, where these agents are actually using language models to do the negotiation, right? And even like be persuasive or be hide certain facts from the other players in the negotiation. And so now we're seeing, language models with GPT-4 becoming much more capable of generating language, but also reasoning and kind of more long-term planning. How do you see the parallels between your work here on climate negotiation and, let's say, work on diplomacy? And how do you see that evolving in the light of, language models becoming more powerful in the next few months even, or years?
Yeah. This is a super, sort of topic of the day, right? On diplomacy, that's amazing work. I know the authors, and the way that you can think about our project is that it's sort of asking the inverse game theory question. So in diplomacy and CICERO, they said we're given the rules, right? We're giving all the pieces, and we're going to use language models and reinforcement learning to train an agent to beat people at that game, right? But it's a fixed negotiation game. So here in this project, we're asking the inverse. We're saying, what are the right rules and what are the right types of negotiation that lead to more cooperation, right? So it's like the inverse of that question. But there's definitely some connection there. And in terms of language models, I think it's a fascinating area, and how what's fascinating is like how does language, how does text inform strategy, right? And how do language models negotiate, help us negotiate? So there's different like parts of the problem that you could imagine language models being useful. So and so the first one is, as I said, when you think about negotiations, there could be a lot of text out there, right, about historically, like what people have discussed, what were the outcomes, what were the contracts, what were the results, or what were the behaviors that countries had after those agreements were reached. And you could use language models to read all of that, and then based on that, perhaps suggest like other types of negotiations, or maybe suggest some things that you should say during a negotiation, or maybe come up with contracts, for instance, that you should negotiate about, right? So there could definitely be this sort of strategic planning element that these language models could help with, because they've read all that historical text, right? So yeah, and that could be very useful to inform the design of negotiations. It could also be useful in terms of training agents for this climate negotiation game. So for instance, you know, if your country, maybe you could say, well, I'm going to make my own CICERO bot, right? And I want the CICERO bot to help me negotiate in the upcoming climate negotiations, because that bot has seen all the, you know, everything we've said before, right? And like, you know, and we might have some indication of, well, what we said back then was successful and was useful, and what we said, you know, what you know, maybe something else that we said was maybe not that useful. And these large language models might be able to really analyze that whole corpus of texts much more quickly, much more thoroughly than humans might ever be able to do.
So you do see a future in this line of work where AI models, probably under the supervision of humans, are able to act as strategy advisors in complex multi-agent games?
Yeah, for sure. I mean, it's definitely, you know, I would say it's not impossible, right? I think the interesting question here is that, you know, one of the main concerns with these large language models is hallucination, right? Is the fact that they can dream up facts. So that's great if you're writing poems, right? Or if you're writing prose where you know, things don't have to be necessarily truthful. But if you're talking about climate negotiations and optimal strategies, then you probably want to make sure that whatever the language model is saying is in fact factual, right? Or based on real facts, and that the logical inferences that it's drawing are in fact correct. So yeah, like, you know, I think when you want to use it as a strategic advisor, you will have to deal with this hallucination problem, right? And I think that that's something that we'd have to do more research on. The other thing that's not so clear is that even if the language models is suggesting a strategy, a lot of the devil's in the detail very often, right? So, you know, ideas are cheap, execution is very expensive, right? And execution really, it's about the little details. So maybe the AI bot says you should really negotiate harder on mitigating, you know, or cutting fossil fuels, but really what you need to say is like, oh, how many tons of fossil fuels less, right? Like maybe, and it's not so clear that that level of detail is something that you can always really, you know, get out of the model in a very reliable way, where like, for instance, the range of the, you know, amounts of fossil fuel that you should negotiate about, are those ranges in fact the optimal ranges, or is it just something that the models come up with, right? So, you know, is the strategy in fact close to optimal, or is it just like a good idea? You know, that's not so clear, but certainly it's like a fascinating direction to look into, right?
Right.
Yeah.
So wrapping up, what is kind of next steps for this AI for global climate cooperation? Are you guys organizing some workshop or some next steps?
Yeah, so April 26th, in about a month, we're going to have a workshop that's going to do a review of the first phase. So in the first phase, we had this competition. So we had multiple teams who are working on this problem, and then they were to submit their solution and a write-up and sort of an explanation of what they found. And then on April 26th, we're just going to have a little 3-hour get-together. We're going to have some talks with some of the teams. We're also going to have some talks by the jury members and by ourselves to sort of do a retrospective of what we've learned. And then in the next phase, we're still brainstorming about it a little bit. But there's definitely a big appetite to take this further. So, you know, there's definitely a lot of communication we've had with various experts. So, you know, people in climate science, people in economics, political science, who've looked at the simulation and you know, have given us their take. And so, you know, I think high level, the next step is to have a group of people who are all really interested in sort of one specific framing of what we could do with this climate economic framework and AI, and then to work together on that. But that's something also that we want to discuss at that workshop. So if you're interested, if you're listening, then, you know, please join us, and, you know, it's free for everyone.
All right, Stephan, that ends our interview. Thanks for talking about your work on trends in AI from Zeta Alpha. We will be including some links to the work you mentioned in the written interview. And well, thank you.
No, thank you for the opportunity to talk about my research. And yeah, thanks for your time. And thanks for listening, for anyone who's listening.